All right, guys, I'm back at you with another fun problem here. I just did number 17. That was good. You saw me fight through it. Hopefully you picked up some of that perseverance type stuff of labeling it down, trying to see it different ways, forming connections also to previous chapters. What did I learn today and what follows from that, right? So what helped me was perpendicularness of those tangent lines. And then I realized, ooh, these got to be parallel, basic proportionality theorem. QT divides this triangle proportionally. So hard thing to see, right? That's one where normal day-to-day class, when we're posting answers to the whiteboard, right, or the chalkboard as I had last year, it's like I'm expecting maybe that group not to get that one. And that's okay, right? Some of these questions, they keep you up at night, don't you? Want to get there. It's part of life, man. Part of life. So you got to learn everything. It's all good. Just search for it, try to persevere. That's what it's all about. All right, question number 25 here. A circle inscribed in a right triangle ABC is tangent to hypotenuse AB at K. We got AK equals 20, BK equals 6. Find the sides of triangle ABC. Hey, this year in and year out, it's kind of a challenging problem because it actually, this one's going to involve some Algebra 1, some late in the year Algebra 1 stuff. So anyways, figured I'd show it to you. So first of all, this is a circle inscribed in a right triangle. So the circle is inscribed, the right triangle, okay? Circle is inscribed. So that means inscribed. Whenever we see inscribed, you need to think inside, okay? Inscribed, inside, okay? A circle, because we can think about this, a circle is inside a right triangle, ABC, and it's tangent to the hypotenuse here and whatnot here. So so this is a few things here, is that we have a triangle ABC, and this would be a circumscribed, right? Circumscribed triangle ABC. Okay, so you have the idea that a polygon can either be inscribed, in which it's inside a freaking circle, and all of its vertices of the polygon would be on the circle, therefore be inside, or you have this idea of a circumscribed polygon, where all of the sides are tangent, right? All the sides of that polygon are tangent to the freaking circle, okay? And if we say that the actual polygon is circumscribed, then the circle is inscribed within it because the circle is inside the actual polygon. Okay, so here's how this looks. Maybe you got a little turnaround by this. Maybe you didn't quite get it. I want to start by drawing the right triangle, and then I'll inscribe the circle to it as best. Actually, that's kind of messy here. Let's actually draw the circle first, then it's easier for me to draw the right triangle because, yeah, you would have seen, there's no reason to do it here as I was potentially going to show you here. There we go. There's a circle. We'll take it here. This isn't perfect. I don't have my construction tools here to draw it perfectly. I'm just going to eyeball it, right? Eyeball it this year. It's all about, I'm not doing constructions this year, unfortunately. Constructions. Fun times. Okay, and let's go ahead and draw in a right triangle that, well, easy enough here. Maybe we'll just do this. We'll do a right angle right here. Okay, and I'm going to draw that side, that leg, tangent, right? Tangent to the circle here. So it's going to be a segment. It'll be two tangent segments, right? Technically one segment, but oh, no. Didn't work exactly. Maybe I'll start from a point of tangency and kind of do it. There we go. All right, looks good enough here for demonstration purposes, okay? And then we have this here, and then here, we'll go at a right angle, and hopefully it looks tangent. Close enough. This looks a little cute, but all right, I got to keep going because I got to actually have my third side, my hypotenuse, also got to be tangent. Anyway, this is as far as I'll go, and then here, let's draw it tangent. Okay, there we go. It's about as best as I can do. Ooh, not bad. I'll take it. A- for effort here. There we go. Finally, close it up. And there we go. There we go. We got ourselves our circumscribed polygon. There we go. All three sides of this three-sided figure, this triangle here, they're all tangent, right? All tangent here, okay? So here, this problem, you might be asking yourself, again, this is what I want you to start thinking about. I got this diagram. I'm not going to read this. I'm not going to read the whole thing here. What is this diagram? Well, I'm going to read the beginning, like it's this, like a circle inscribed in a right triangle ABC. Maybe I'll try sketching it out and think about, well, what might it be asked to do right now? What skills might I ask to do? What things jump out to you, right? Start getting things now. Mark it out. What follows from this, from a diagram? What would follow? Think back to the video. What can we mark up? What can we know? Well, we know that from a point outside of a circle, you can draw exactly two tangent segments to the circle. And those tangent segments here are going to be what? Going to be congruent. So those are congruent. Okay. What about these two? Well, this is from a point outside of a circle, tangent segment here. So tangent segments drawn to a circle are congruent. That was our second theorem in yesterday's lesson. Finally, what do we know about these? Also going to be congruent. Here we go. Because, yeah, let's go. Because any point outside the circle in the plane of the circle, you can draw exactly two tangent segments, and those two tangent segments are congruent to one another. Okay, neat, right? Definitely something that's worth knowing. And maybe we need to actually mark this one up because this is triangle ABC. Let's see, hypotenuse is AB. Okay, so let's pay. Now we aren't paying attention because I know that this is going to be true because of what we studied today. I think we're going to apply it. We're going to apply it to the situation. Help us solve this problem here. So now, what does the problem actually say? So think, what diagram are I given? What follows from it? And then, well, what's the question asking me? Is it actually what I'm anticipating here? So AB is the hypotenuse. K is the point of tangency there. So here, every side of a circumscribed polygon is going to be tangent to the circle. They're just giving the letter for the hypotenuse side there. And I guess that's the only one that really matters here because it's telling you that BK equals 6 and AK equals 20, okay? Now I'm thinking, right? I'm not even going through the whole thing. Now I'm thinking maybe I'm using Pythagorean Theorem on this problem, right? Because they're giving me the freaking hypotenuse right here. So this is, and I might start marking this in, well, it's got to be 26 from the segment addition postulate, right? Because 6, which is BK, KA is 20, right? And they're collinear, and K is between B and A, so I can just add those two sides up and side lengths up, and then I'm going to know that, right? Part plus part equals whole, segment addition postulate. We've been dealing with that since section 1.3. So I got 26 here, and then maybe I'll master, so it says find the sides, right? Find the sides of triangle ABC. So then you're thinking, I have one side of the right triangle. If I had an angle, if I knew an angle other than the right angle, which I might put the right angle up here. If I knew an angle other than the right angle, I could use trig to solve this problem. I can use trig and get done with it. Can you use trig right now? No, you can't use trig because you don't know what angle B measures. You don't know what angle A measures. So when you have an angle and a side of a right triangle, use trig. Not going to use trig. What do we got to use? Oh, Pythagorean Theorem. Can I use Pythagorean Theorem? I can't because Pythagorean Theorem is for when we know two of the sides of the right triangle. And here, we know one. We only know one, okay? So maybe let's see if we can apply something. I already marked it up for you guys here. This is what follows from it, okay? Well, let's see if we can add more intelligence. Let's add more to our diagram here. Just what follows and what can we apply? What can we think through, okay? So they gave you AK is 20. So what else is 20? Okay, this distance here from A to that point of tangency is also going to be 20. Okay, this from B to this point of tangency, well, BK was 6. Tangent segments from a point to a, tangent segments, I don't even say from a point to a circle, because that's what a tangent segment is, at a point of tangency, they're congruent to one another. So this is 6 and this is 6, okay? So then, right, the key to this, well, I know part of this leg, I know part of that leg, but I don't know the whole leg. I don't know the whole leg. How am I going to get the whole leg? Well, it turns out there's really only one unknown left in this problem, okay? We know what this 3 tick mark thing means. It means 6. The 3 tick mark thing means 20. This 1 tick mark thing means 6. And we just don't know what these 2 tick mark things make. So what can we do? How can algebra help us in a problem like this? Well, we can assign it a variable. We can make that x. We can make that x. And there, boom. We have one variable in this problem. And you know what? We have a method to solve for that variable. What's that method? I know what side AB is. I don't know what side BD, if this is D here, or AD is right here. But I can set up an equation, right? I can have to set up an equation where x is going to be the only variable. What's that equation? What's that equation here? Well, how can I set up an equation with a right triangle? What equation are we looking for? What formula? Pythagorean Theorem, baby. Okay, so we're going to use Pythagorean Theorem. I got this, right? If this is x here, this from this tangent segment the circle's x, this tangent segment's x, but then this other tangent segment is 6, then this whole side length here is x plus 6. Okay, that's what side DC is here. So this leg is x plus 6. The square of that leg is x plus 6 squared. You got to remember how to do that from Algebra 1, how you square something like that. Common mistakes people see too. Common mistakes we see. That's why I want to practice that a lot. I want to practice that a lot through Algebra 2, beyond, pre-calculus, all that good stuff. A lot of people make mistakes on that. Ooh, don't make that mistake. Use the box. Use a generic rectangle. Use FOIL. I don't know. Some of that should have rang some bells here. Okay, that's x plus 6. What's this one here? Well, this leg is the whole thing, right? X plus 20. Part plus part equals whole. Okay, so I got here x plus 20 squared for that leg. And what does it have to equal? Well, the sum of the lengths of the squares of the legs of a right triangle equals the square of what? The remaining side, the third side, the largest side here, right? So 26 squared. And there it is here. We've set up an equation using Pythagorean Theorem. Boom, it looks beautiful. And now we're good to go, okay? First up first, this, x plus 6 squared. Here's why I say use a generic rectangle here. Because remember, a square looks kind of like that. I use a generic rectangle for these. I break up my terms of this here, meaning I'm doing x plus 6 times by x plus 6. You can do FOIL, right? FOIL is another method that's been taught for decades, and that's the way that I learned growing up. FOIL of how you do x plus 6 times by x plus 6, right? This whole thing represents x plus 6 squared, right? Base of our square is x plus 6. The height is x plus 6, and that means we're going to find x plus 6 squared. How we can rewrite this, not as a product, but as a sum. Anyways, x times x is x squared. 6 times x is 6x. That's probably something you forgot if you made a mistake multiplying this. 6 times x is also 6x. 6 times 6, 36. So what this simplifies to is not x squared plus 36. No, you wouldn't have been multiplying all the terms there. You would have gotten x squared plus 12x. Okay, like check it out here, right? That diagonal here adds 12x. We got 12x's here, we get an x squared there, and we got plus 36 at the end. There we go, okay? So that's what that one simplifies to. Here, I'll go through this a lot quick. I'll do this one in my head just because might as well go faster. If you understand what I was doing there, you'll understand this. X squared, okay, would be x times x. X times 20 would be 20x. But you got to do that twice. Here, maybe I'll show you FOIL. This is what FOIL is. Okay? FOIL. FOIL stands for this. Okay? FOIL is a way of remembering how you multiply two binomials to one another, or something being squared here. First, outer, inner, last. Okay? First is this. First term to first term. X times x is x squared. Okay? Outer terms, right, are the outer ones in both the binomials here. So 20 times 20 is 400. Okay? So I'm going to have a plus 400 over here. I'll maybe save that for later. There's outer. Inner are these inner guys here. So you want to multiply every term to every other possible term. There are 4 terms here. You're going to multiply 4 times. 20 times by x is 20x. Okay, that's inner. And then finally last. The last term, I did the last already. That's the 400. Outer would have been this. X times 20 here, right? The outer terms of the whole thing. FOIL, just use a generic rectangle. You're fine. Anyways, x times 20 is 20x. 20 times x is 20x. So, hey, we got 40x's total. There we go. Plus 400 equals 26 squared. I can't do that in my head. Get your freaking calculator going. Do it. Where's my calculator? Where's my freaking calculator? Okay, we got 26 squared on up. I got 676 there. Boom. We got it, all right? Now we got to solve for x, my friends. We're going to use maybe the quadratic formula or factoring. I just did a whole unit on factoring with my algebra 1. So maybe I'll do factoring with you guys here because I'm hoping in algebra 1, potentially you've done some factoring by now. So maybe that's what we'll do. Okay? So here, now I got to combine like terms. I got to solve for x here. Tricky thing here is that I got an x squared here and I got an x squared here. Add them together, how many x squareds are those? Well, you got one x squared plus another x squared. Brings me up to 2 x squareds here, okay? Then I got 12x here, and I got 40x there. So I'm going to add them together. I'm going to get 52x here, okay? And now I got 36, and I got 400 here. Let's add them together. I got 436 for my my ones term here. Basically, I'm going to x term here, my x squared term here. Just combine my terms. And then I got 676 over here. So maybe what I should have done is this. I should have maybe, I'll put the 436 here for a second. I should have subtracted 676 from both sides. I'm getting a little ahead of game here. Maybe I'll leave it here for the time being, okay? I'll leave it here for the time being because I don't want to go too fast for you here if you haven't done too much algebra 1, okay? So now I got this. Now you might be thinking, hey, I got an x squared. Again, if I figure this out, I'll be able to figure out all the sides, right, if I get x here. So anyways, now you got this, and you're like, wait, how do I solve an equation with x squared in here? Well, when you have x squared in here, it's something called a quadratic equation, right? Quadratic just means it's a 4-sided figure. It's like what I just showed you. This is a quadratic thing, 4 sides, right? Quadrilateral, 4. Quadratic is when you have x times by x, creates a square, right? Creates a square. So anyways, this is a quadratic equation. How do you solve quadratics? Well, I could use the quadratic formula. I could also factor, right? Factor, or I could complete the square and solve solve for the perfect square. But anyways, we're not going to do that last one here. So I'm not going to do the quadratic formula because I already talked with you guys about that earlier this year. Anyways, you'll learn that in Algebra 2 again if you forget it. Like, we don't have time to do it this year. Anyways, so I think I'm going to solve by factoring. Okay, solve by factoring. So this might ring a bell on this from last year. Okay, I'm going to show you the way I do it. There are other ways you can factor, but I'm going to show you the way I do it. And actually, I'm going to show you involving the rectangle. How do I set up my terms in a rectangle where I can actually factor it? Do you remember that? Factoring using a rectangle and a diamond? Oh, maybe you don't. Oh, maybe a different teacher. Maybe they're like, what? We're not doing it that way. Let's see if we can do it here. So, okay, one of the things we want to solve this for, the way you solve quadratic equations is you got to get them equal to 0. Okay, that's one thing you got to remember when you're doing quadratic equations. Again, I'm not your quadratic equations teacher. I gotta do a quick review. You got to kind of pick that up. I'm spending months, like literally months. Like I've been doing this maybe 2 months quadratic stuff, and I'm doing the rest of the year. So my freshmen, they're getting like 3 or 4 months of this quadratic stuff here. So, anyways, if it's completely foreign to you, come see me some other time, right? And I can go over solving quadratics because it takes time, right, to figure out. Hopefully, you got an algebra one because you're supposed to. Okay, so anyways, this is 2x squared, okay, and then this is plus 52x. This is minus 240. Okay, I want to solve for x here. So, hey, whenever you're solving here too, you also want to say, how can I make my life easier? How can I simplify what's here? There's one actually way you can simplify this equation even more that would still make the equation true, and that is if this is 0 over here, I can actually divide 0 2 ways, right? If I have $0 and I split that to 2 people, how much money am I gifting those 2 people? Well, $0 split 2 ways. Each person's getting $0. So I'm not really gifting it. But anyways, if I divide this side by 2, that's a legal move if I divide that side by 2. Why would dividing this side by 2 be easier? Well, it simplifies this. It doesn't change this, right? Dividing 0 by anything will just result in 0. Here, if I'm dividing this whole thing by 2, all these numbers are even. So it's just going to simplify my expression here. So I'm going to have, instead of 2x squared, I'd have x squared. So here, what I'm doing is I'm just simplifying this before I try to factor it. Okay, 52x divided by 2, that's 26x. Minus 240 divided by 2, well, that's minus 170. Okay, and then that's equal to 0. Now we want to solve for this by factoring and using zero product property. You remember that from Algebra 1? I don't know if you had me last year, you better remember it. But anyways, this is how you do this. Okay, so now I want to factor this. So this is called factoring a trinomial. Flashbacks? I hope at least some flashbacks. I don't know. Factoring a trinomial. Okay, I want to factor this guy here. How do I do that? Well, I got to figure out. And if you can set up a rectangle involving a expression like this, you'll be able to factor it. So anyways, maybe you've done algebra tiles in the past. I hope you have. Okay, this is where x squared always goes, for me at least. I always put this here, right, my ones here. The question is, how do I break up my x's to make this into a rectangle? This might be completely foreign to you. If not, right, you're going to have to study factoring some other way, right? Or your teacher next year will teach you their way that they factor. But this is how I do it, okay? Then I use these diamond problems. You should have at least saw those middle school, I guess, here. But the goal of this is I need to find a number that multiplies to negative 170 and adds to 26, okay, 26. You'll see why in a second when I actually factor this thing. But anyways, that's how you lay out your x's, your amount of x's here, okay? I need 2 numbers that multiply to negative 170x squared, and I got 26 x's to do that, okay? First thing here is what's telling me is I need to have this. One number is negative, one number is positive, okay? That's the only way it's going to multiply to a negative numbers. One number is negative, one number is positive, okay? So that means that my positive number needs to be higher than 26. So how am I factoring this one? It might just be easier to use quadratic formula. So not, should I just do quadratic formula? No, I'm going to stick with factoring. You can do quadratic formula on your own if you want to. But anyways, this is what's factoring. So let's check this one out. So let's see here. 170, well, like 70, no, sorry, what am I talking about? 85 would go into that twice. Okay, and then 5 goes into 85. So maybe it's 17 and 10. Does that work? No, it doesn't work here. Did I make a mistake at some point in time? Here's where I'm questioning things. I got to really question things if I actually did this correctly now. 40x, 400. 12. Yeah, this is all right, I think. I think this is flawless, okay? All right, so anyways, 170. Factors of 170. If it ends in a 0, 17 and 10, that would work. What else? Oh, gosh. Gotta go to my solution to this here. I think I might have made a mistake here. All right, that's You guys still watching this? This is this is terrible. No. Anyways, let's go back to it. I got the answer here. I might have to get bailed out of this one here. Maybe we should have just done quadratic formula. But I kind of feel like I made a mistake at this point here too. Let's check it out. I'm not really filming this video. Sorry, guys. There we go. What do we got here? No, I did it right. Oh, wait. When I divided by 2, did I not? Wait, hold on. Negative 240. 20 times 20 is 400. So that should have been 436. Did I subtract wrong? Yeah, 240 is right there. Oh, I didn't put 170. It should have been 120. Okay, there it is. That's my mistake here. Okay, when I divided, I was really making my life easier by dividing everything by 2. I divided 240. I put 170 for some reason because I guess 140 divided by 2 would be 70. But this is 240 divided by 2. So this should have been 120, negative 120. There's my mistake. Okay, so here, oh, man. All right, it's all good. Revise, revise, revise. Sometimes I make more mistakes too when I'm talking out loud, right? I'm trying to entertain you. Nobody's watching this video anyways. Okay, so now I got negative 120x right here. Okay, 26. This is gonna make it a lot easier here because this is, well, I'm thinking maybe 20 and 6, but that actually doesn't work because this needs to be higher than 26 here. So 30 and 4. Yeah, 30 times 4 would be 120, but if I make the 30x positive and minus 4x, make that negative, 30x minus 4x is 26x. Here's the magic of this here. So anyways, your Algebra 2 teacher might teach you this way. Okay, with the factoring. Again, I'm not really explaining what I'm doing. I spent classes do this in Algebra 1. But anyways, I'm going to put my x here. I'm going to put my x here because I can factor this. What this is our sum. Our product's going to be on the outside. Check it out. This is like magic here. This is going to be plus 30 right here. Okay, and this is going to be minus 4. And check it out here. This expression here, it's equivalent to x minus 4 times by x plus 30. There it is, equal to 0. There we go. It is here. Check it out here. Don't believe me? Well, do the math. X times x, x squared. X times 30, 30x. Negative 4 times x, negative 4x. Well, that's my 26x's right there if I combine like terms there. Negative 120 is negative 4 times 30. There we go. And that's good factoring, my friends. You got it. Okay? All right. Anyways, kind of messy, but we got there. Maybe just use quadratic formula. Anyways, all things, right? All things that you spend just specifically this in Algebra 2 next year, okay? So normally I'd hold my algebra, my geometry a lot more accountable for being able to do stuff like this because you gotta be able to know how to do this to do upper level math, okay? So anyways, if you don't know how to do this right now, you'll get it Algebra 2 next year. All right, anyways, now I can figure out what x is here, okay? First of all, this whole thing equals 0, so that means I have 2 solutions for x technically. X, if this is negative 30 plus 30 equals 0. So 0 times by 30 minus 4 times negative 34. Well, 0 times anything equals 0. So negative 30 is a solution. My other solution here, this is something called the zero product property. I'm going through very quickly just for the sake of getting done with this freaking problem here. X here has got to be 4. Okay, got to be 4 here, okay? Because 4 minus 4 is 0. 0 times 34. Well, and 0 times anything is 0. So that's going to make the equation true. This is going to make the equation true. So that turns out these are my 2 solutions to the equation. Which one is the one that's the answer in this problem? Okay? Well, the answer in this problem is going to be, you guessed it, 4. Why 4? Well, 4 is a positive number. Okay? The x couldn't have been negative 30 here because then side DB would have been negative 24 in length. That makes no sense. Remember, in geometry, we just care about positive values because distances always need to be positive. So this is definitely 4. That means x plus 6 would equal 10. 4 plus 6 equals 10. And then finally, 4 plus 20 is 24. Okay, so I got 24 there. I got 10 there. And then my answer, okay, answer is 10 side lengths. What are they? Find the sides of triangle ABC. Well, I got 10. I got 24. And I got 26. Drop the mic. We got it. I'm out of here. Okay? Message me if you have any questions. Thanks for watching. Take care, guys. I will see you tomorrow. Bye.